Well, I kind of need to start out with a confession. So, I you've heard of clickbait, probably. I don't know what the name for it would be in the context of a conference talk, but my talk is whatever that is. So, I'm using liquid glass as an excuse to talk about one of my favorite, if not my favorite, technology in Apple's platforms, which is core animation. Yes. So I'll get back to core animation in just a moment, but I feel like we have an illegible elephant in the room. I know that liquid glass is surrounded by controversy. So whether you personally like the style or not, like it's true, it works better in certain situations and it can lead to illegible text in some situations, like this one. So my talk is not about preaching liquid glass. And it's also not about the SwiftUI APIs because you just saw that. So, just for the duration of this talk, let's just agree that it looks cool. And I think that's enough. And we can appreciate some of the work that went behind the scenes to actually get something like this to work. And that's why I will have to talk about core animation. So, throughout this talk, you'll see liquid glass in really zoomed up slides like you're seeing here. So I'll break down some different UI components to show you the aspects that contribute to the final effect. And this will hopefully be inspiring, or if it's not, at least you can look at pretty pictures on screen. I got a bit excited and developed a bunch of custom tech to make this talk to like capture core animation layer hierarchies and render them using Metal into 4K video files, which is what I'm playing to you here. But I don't have time to talk about that. So if you are interested, come talk to me later. I can show you some stuff. I love nerding out about this stuff, so feel free. And something to note is that liquid glass is not composed of a single effect. It's not one thing. It is a combination of many effects that create the illusion of a glass material, as you can see here. And if I zoom in on the step bar and start turning off individual aspects of the effect, you can see how much layering occurs and how much stuff is going on. And we'll see more of that very soon. So given that pretty much all of liquid glass is implemented using core animation under the hood, let me walk you through a quick crash course about it. Can we get some lights in the audience, please? Because I want to ask you, how many of you here know what core animation even is? That's more than I was expecting, actually. Maybe we can skip a bunch of slides. How many of you have ever actually done any code that involves core animation? Good. Nice. Yeah, but I will bring up a brief explainer on core animation because we're at a point in the history of Apple's platforms where it's very possible for you to have been working with them for quite a while and haven't even heard about core animation. But if you've written any UI code for Apple's platforms, you have in fact been using core animation in your apps because it's behind everything you see on screen. Every view in an app has a core animation layer backing it. Asterisk, macOS, maybe not, but that's not relevant here. But even if you're not touching it directly, you are using core animation indirectly. A little bit of a history lesson. It was developed back in the mid 2000s. It was initially called LayerKit, if I'm remembering correctly. So the idea was to have a higher level framework for animations where the developer could just specify the beginning and the end states of an animation, and then the framework would interpolate and create the intermediate steps and just render a pretty animation for you. So it was first previewed publicly as part of what was then upcoming macOS 10 Leopard in 2006, but it's public debut was probably in something you're more familiar with, which was the original iPhone back in 2007. So, to quote Steve Jobs, to write apps, it's got everything from Cocoa and the graphics, and it's got core animation built in, and it's got the audio and video that OS X is famous for. And to also quote Steve Jobs, boy, have we patented it. So, yes, core animation is actually patented. There is a patent for core animation. It's actually really interesting reading. It goes in depth into a lot of very technical stuff. I hope I don't get a letter from Apple's lawyers after this talk, but yeah, it's interesting. So, with history out of the way, brief primer on how core animation actually works. Some people would probably describe core animation as being declarative, even though that's like if you compare it to Swift UI, it doesn't really feel declarative. But the ideas behind it do align quite well with the idea of the declarative framework. For example, core animation has a layer tree, which is the interface that the app uses to talk to the framework, but it also has a separate render tree, which is the interface with the render engine, in most cases, the operating system's Windows server. If you've read any articles or seen talks about how Swift UI works under the hood, you'll probably notice a familiar concept of having a view tree, which is like the model for your views, and a render tree, which is the presentation for that view. And we can visualize that here because core animation has the same concept. Every CA layer has a model layer, which is the layer that's been created by your app, and a presentation layer, which is created by the framework after applying any state changes to the layer tree. And those state changes are typically animations, which will modify the appearance of a core animation layer, such as changing its position within its parent layer. In this simple example, a layer is created with a background color and position within its super layer. A basic animation is added to move the layer from side to side indefinitely, even though on the slide it's not indefinitely. I'm sorry about that. If at any point you were to access position.x, it would print out its original value. Even though we're moving it to 500, it would still print 100, even if you are in the middle of the animation, because that's the model layer. That's the blueprint of your layer. What differs in core animation when you compare it to Swift UI is that it allows you to get to the presentation or the render tree. So you can call presentation on any layer and it will give you exactly what the layer's properties are at that specific point in time. And it can return nil because it's possible for a layer to not be in the render tree if it's not on screen or it hasn't been rendered yet. So in this case, I did something a little bit dirty. You shouldn't do this with relation to animations, but I did an async after and got an approximate value for that particular point in time. So hopefully I've given you enough to understand the principles behind core animation, because now it's time for us to dig deeper. Even those who are familiar with core animation are likely familiar with its public API, but if you know me, you've probably seen where this is going. To understand how liquid glass works under the hood, I'll have to talk about private API. Scary. Now, disclaimer, I'm not proposing that anyone should use any of the private API discussed here. I'm just talking about it in the context of understanding how these things work. It's for educational purposes. So there are several types of core animation layers we can use, such as the basic CA layer, if we just need a rectangle that can have other layers, or you can have a background color, borders, masks, etc. There's CA gradient layer for gradients, CA text layer for text, CA shape layer for Bezier paths, and so on. But there are also some really cool core animation layers that Apple reserves for their own use, aka private API. And one of those is CA backdrop layer. I think the best way to explain it is to show an example. Here's a car animation composition with a basic layer, and it has a wallpaper image as its contents. Now I'm going to place a backdrop layer on top of it. All right, now it just looks like placing that backdrop layer has reduced the quality of the image, so not really useful. Well, now let me add a couple of filters to the backdrop layer. As you can see, by adding a saturation and a blur filter to the backdrop layer, it creates an interesting frosted glass effect. So a backdrop layer will capture the composited image of whatever is behind it and render that image as the layer's contents. Any filters applied to the backdrop layer will filter its contents, which just happen to be whatever is behind it. If I add another layer between the wallpaper and the backdrop and move it around, the layer will be blurred as well. And that's the key technology behind the blur effects that they've been using since iOS 7. The difference with liquid glass is that the filter being used is not just a blur or a saturation, but specific filters created for rendering the glass effect. You saw about like the sampling region. So the backdrop layer is what provides this sampling. So it's sampling what's behind it, and that's important for liquid glass to work. I mentioned adding filters to a backdrop layer. That's another important aspect of car animation that's not widely known. On macOS, for some reason, you have been able for a long time to add car image filters to your layers, but that was never really a thing on iOS. However, there is something called CA filter, which is private API, and that exists on all platforms. It renders in real time, so it can render real time effects like blurs, color adjustments, and it all happens on the GPU, making it perfect for use in UI elements. Another layer type that will be important to understand for the liquid glass effect is the aptly named CA portal layer. And what a portal layer does is it copies a source layer into it as if the source layer was a sublayer of the portal layer. Uh, Take a sip every time I say layer in this talk. Anything that happens with the source layer will also happen with its copy in the portal layer. And this allows a single layer to be visualized in multiple places at the same time. And the cool thing is that any changes I do to the portal layer, such as adding a blur filter, will be applied to the copy of the layer. So this allows a single layer to be rendered in different ways, which you will see very soon that can be very useful to create certain types of effects. Everything I've shown you so far has been around in core animation for quite a while, if not since it was introduced. But in iOS 26 and friends, core animation gained a bunch of new private types to support liquid glass, and they all have to do with something called signed distance fields, or SDF for short. That's the blobbymorphy part of the talk. I don't want to bore you with a bunch of math, which honestly I don't completely understand myself. So let me propose a simple mental model to understand sign distance fields. Think of a shape, like this circle here, for example, but it can be a rectangle or any other shape. Now imagine every pixel asking, how far am I from the edge of this shape? Quite an existential question for a pixel to be asking. If you're inside the shape, the answer will be a negative number or distance. If you're on the edge, it will be 0. If you're outside, the answer will be a positive number. So a sign distance field is a function SD of p that maps any 2D point to its sign distance from the shape's boundary. That sounds like, okay, it's so simple. What's the deal? Well, you can do things like this. So it's a very powerful concept because it can turn these distance values into pretty much anything, like crisp rendering of shapes at any scale, smooth borders, glows, outlines, soft shadows, and you can do it quite efficiently. In fact, This is a metal shader I wrote myself, and I am not very good with shaders. With some help from ChatGPT and stuff like that, I was able to get this working, and it was surprisingly little code to get something that looks kind of interesting. And there are, like you're seeing here, techniques to do the blobomorphy part, which is combining multiple shapes in an image, such as joining shapes if they come very close to one another. And you can also subtract, intersect, and do all the Boolean operations. And what you can also do with these distance fields is you can turn them into refraction normals. And once you have refraction normals for a given shape, you can use those values to render actual glass refraction effects. And that's exactly what happens behind the scenes for liquid glass. And in liquid glass, that's happening at the metal level. So they have metal shaders doing the actual work. But the way it's brought up in the higher level part of the system that actually interacts with your app is still just core animation. But that will bring us to the new private core animation layers that are used to implement liquid glass. The most important layer is CA SDF layer. Now you know what SDF means. You probably have an idea about what it can do. If you think about the SwiftUI API, this is like the glass effect container. However, this layer type doesn't really do anything on its own. To get an effect on screen, it needs to have CA-SDF element layers added to it. So as you can see, once I add an element layer to this SDF layer, it begins to render an interesting, colorful image. What you're seeing here is a normal map that's being generated by the SDF layer based on the elements within it. And that's not very useful on its own, but watch what happens. You remember those CA filters I talked about? There is one called glass background filter. Watch what happens when I add a glass background filter to the parent of the SDF layer. Starting to look more familiar. What's cool is that it all happens in real time. So if I add more element layers, change their shape, or move them around, the effect will follow. SDF layers also support smoothness, which in the public API is what you saw as spacing. And as this value is increased, element layers that are further away from one another will begin to merge into a single shape. But as you can see in these demos, the glass effect is not as vivid as what we see in Apple's UI. And that's because, as I mentioned before, liquid glass is composed of multiple effects. And this demo here is showing just a single layer of the effect. And you can see how it starts to look a lot more interesting once I turn on some of the other layers of the effect. So you might be wondering, what's the deal with the core animation layers you talked about? So they're being used here. A backdrop layer is used as the container for the SDF layer. And since backdrop layers sample what's behind them, the glass background or glass foreground filter, which we'll talk about soon, is applied to the backdrop layer. These filters are configured with the name of the child SDF layer that provides that normal map texture for the filter to actually render the effect. And since the same SDF elements are supposed to be rendered for any additional SDF layers, because you will have multiple of them for the different layers of the effect. So instead of adding elements directly to the SDF layer, because you want the actual things inside the blobomorphy to be the same across different effects, a portal layer will be used to just copy all of those elements from the main SDF layer, ensuring that all effects stay in sync, even if the elements change over time. So let's walk through a UI element from iOS 26 and see how different parts work together. So I'm going to use the toggle control, as it uses quite a few different effects. And the most interesting part is the actual knob that becomes this liquid lens when you're interacting with it. And I'm going to build the effect up one part at a time, starting with the displacement of the background, which consists of a backdrop layer with a displacement map filter, which is yet another filter. And that does the part that displaces the content, and it bases that displacement on that SDF normal map that's generated. So then we have a second one, and the second one is where the glass background effect is added. And as you can see, when I increase the refraction amount, which is one of the many parameters in the glass background filter, it refracts the content behind it. Seriously, it's like probably like 50 different parameters that this glass background filter has, so I won't be able to go over all of them. Then there's blur. It's subtle, but it's there. So it kind of blurs. And there's also a configuration for like how far from the edge the blur is and things like that. Then there's a phase effect that adds a little bit of an opacity to the glass, so it's not completely transparent. There's also a shadow, which in the case of the toggle is set to a green color when it's in the on state, so it gives it a little bit of a green glow. Then there's a shadow, which maybe you can't even see here, so let me exaggerate it a little bit. So it's there. Still not done. There's yet another backdrop layer with a configuration similar to the one that adds the background effect, the glass background effect, but this one uses the glass foreground effect, which adds the chromatic aberration that you see here. And you may have seen this effect in the iOS 26 lock screen. Looks kind of like this. And finally, there are two additional SDF layers that use different modes. One of them will draw a specular highlight, and the other one will draw a dark rim, adding even more depth to the glass element. And this simple layer stack here, simple, is what creates this liquid lens effect. I wish I had more time to tell you all about some other stuff, but unfortunately, that's all the time that I have for today. So it's an overview, even though it's a deep dive, but it's a deep dive not very far. And as you can see, there are lots of moving parts. And hopefully, this talk has helped you appreciate liquid glass even more if you like it. And if you don't, at least you can see how much effort went into implementing something that you don't like. Thank you very much.
All right, let's get started. So thank you, Guy. I have a question for you. You spend a lot of time looking at liquid glass, how it works, and I guess how people use it. Have you seen people that have been like crazy enough to try and implement this into their app to have their own custom variation of liquid glass? Or does no one dare to try something like that?
There's a guy, I think his name is like Rambo or something. So actually, like I haven't really done much because you get so much for free with Apple's implementation. Like the whole one of the things I wish I would have more time to talk about, but I can talk about it now, I guess, is like everything you're seeing here, these core animation layers, that's not even what Apple engineers are using most of the time. What they're using is a private SwiftUI API. So just like we have regular, clear, and interactive glass, they have all of these other types of glass they can have, and they have more knobs to fiddle with. But even they are not going so deep as to like mess with the actual layers. So I would definitely not recommend it, but I think it helps to know how it works to make better use of it, even if you're just using the high level API.
Yeah, it makes sense.
All right, I got quite a few upvoted questions. First one, is it possible to recreate this effect without using private APIs on iOS below 26?
Yes, you can write a metal shader and have it do it. It's not easy.
Has anybody done it yet?
I mean, I don't know if you've heard, there is this amazing website called Shader Toy. I think it's shadertoy.com. And it's basically like people create shaders using its GLSL. So it's not the same as Metal shader language. But I saw someone posted like Liquid Glass, and they have like a perfect reproduction using web APIs. So it can definitely be done. It's not, I think I would say it's not the most difficult thing in the world, but it's also not the easiest thing in the world.
All right, cool. Got upvoted and moved. Here we go. What is the performance impact of glass effect compared to the well-known frosted glass effect? And for my own help here, what is frosted glass effect?
So that would be like the iOS 7 style, the traditional
Got it. Well known.
background
Okay.
blur.
Yeah. Okay.
So there is a higher impact on performance and by consequence battery impact. Apple was pretty good, I think, on fine tuning the effects. So for each version of GPU that supports liquid glass, they have different tuning parameters to make the effect more or less impactful on performance. But anything that's blurred, that backdrop layer I talked about, it has a scale property which defines like what's the resolution basically of my sampling. And the higher the scale, which goes from 0 to 1, being 0 to 100%, the higher the scale, the bigger impact it has on performance. And if you are blurring something, you can get away with a smaller scale because it's blurred, so you can see the pixelation that occurs. So yeah, the frosted version is technically more performant than the non-frosted version.
We have a new highest upvoted question now. Where do you find all of these private APIs?
You look. Yeah, so I've been doing this for a long time. I think I gave a talk about this a while back, but you have to look into reverse engineering and learn how you can drop Apple frameworks into a disassembler and find out like what the private classes are. I mean, it's a niche, but it's fun. It can be fun and tiring sometimes. But I would recommend at least like dipping your feet into that because it can be useful sometimes to debug stuff.
All right, we're gonna do two more questions. I have one small one that I'm gonna make up, and then one that is completely unrelated. Do you prefer digging into private APIs or reading documentation?
It's funny because sometimes I will be digging through disassembly and reversing something, and I will realize, wait, this is probably documented somewhere. I should probably read the docs first. And it has happened before where I was like, how do I do this? No, this can't be public API, so let me just like crack open the disassembler. And it was public API, and I wasted a bunch of time. So, but it can sometimes be better than documentation, to be honest.
All right, and then unrelated question in all caps. When is the Stack Trace podcast coming back?
I knew it. I knew someone was going to ask that.
Make the announcement.
We don't talk about future products. So like John had a kid, and probably a lot of people can imagine how much time that takes. We're still really good friends. We talk pretty much every day, but
Just record it.
maybe, yeah. But we can't promise anything. But I will say we haven't had the talk of like, oh, we should never do it again. So it's always a possibility.
Got it. Okay. I think that is all the questions now. Thank you so much.
Thank you.
Thank you.